AFM, Active Fuel Management Technology, it's a very fascinating technology, one we're very proud of. We've had in production for many years now, predominantly on our small block overhead valve engines, because the technology adapts itself very well to overhead valve engines. Effectively, what AFM does is it disables 4 of the cylinders on this V8 engine. During light load, steady state cruise operations, when you don't require all the horsepower of all 8 cylinders, and when we turn off those cylinders, we're actually turning off the intake and the exhaust valve, so those valves stop functioning. Well, this is the actual device known as the lifter, which controls the intake and the exhaust valve events. Each valve has its own lifter, but unlike a conventional lifter, this lifter is very unique in that it has the ability to collapse on itself. We use oil pressure to control whether we lock the lifter together, which allows it to open and close the valve, or whether we disable it through the AFM system and the lifter actually collapses on itself, which results in keeping the intake and the exhaust valve closed. The oil control system goes through a device called the LOMA, Lifter Oil Manifold Assembly. It has circuitry in it, has solenoids in it that controls the oil flow to these lifters, and we use our ECM, our electronic control module control, when we activate and deactivate these lifters. Due to computer control systems, we're able to turn them off at precisely the right time, so the transitions in and out of 4-cylinder mode and 8-cylinder mode are instantaneous and transparent to the driver. And it's almost impossible to discern when you go into 4-cylinder mode. But by turning off those 4 cylinders, we're able to reduce the pumping work of the engine and significantly improve its brake-specific fuel consumption, or the amount of fuel it uses to make a certain amount of power. Like VVT, where we're using variable valve timing to reduce pumping work, when we turn off 4 of the cylinders, we're able to unthrottle the engine, opening the throttle significantly farther, which reduces the amount of energy it takes to pump air in and out of the engine. AFM by itself is a 6% improvement in brake-specific fuel consumption, but coupled with the variable valve timing device, the two are almost synergistic, and we're able to really expand the range of each. They complement each other very well, and we end up running with higher speeds and loads with both AFM and variable valve timing to extend the range, which improves fuel economy over a higher range of actual driver usage.